Alright, so we will pick up with the rest of 13.4. So this is also using half angle identities. The difference now is that they actually give us the angle. They weren't giving us the angle before. So for this first one, we're using cosine. And what this means is that 255, that is some angle that you took half of. That represents your theta over 2. So you have to find out what theta is. So if theta over 2 is 255, how would we get theta? We would multiply both sides of this by 2. 255 times 2 is 510. So that's what we're going to use down here. So we'll use this formula. Okay. Theta over 2, 255, by the way, here's 90, here's 180. 270 is down here. We didn't quite reach 270, so that means 255 puts us in the third quadrant, where tangent is the only thing positive. So that means we're going to pick, out of this plus or minus, we're going to pick the minus right there. And then we'll have 1 plus cosine of theta, and we just found theta. So this is where mistakes happen. What do you plug in for cosine of theta? You plug in cosine of that angle. Don't plug in that angle, plug in cosine of that angle. So cosine of 510, and that whole thing over 2. Okay, now the next thing is, how do we find the cosine of 510? Let's look at the circle again. So there's 360 right there. That's another 90, so that would be 450. If we go around again, that's 540. So that means 510 is somewhere in this quadrant right here. That's 510. And how do you get from 510 down to 540? That's another way of saying, what is this reference angle right here? And that reference angle is 30 degrees. Okay, but because 510 puts us in this quadrant, in the second quadrant, and I don't want to confuse you, notice over here 255, we said that was in the third quadrant. We're not dealing with 255 anymore. That was just to decide on this negative sign right here, the theta over 2. 510 is the actual theta angle we're dealing with. So that's like the cosine of 30. 510 is like the cosine of 30, but it's the negative cosine of 30 because we are in the second quadrant where cosine is negative. Okay, so now we just need to simplify this out. So the cosine of 30 is radical 3 over 2, but it's negative, so negative radical 3 over 2 over 2. And this is going to be 1 is the same as 2 over 2 minus radical 3 over 2. That's all over 2. And let's simplify that some more. So if you divide each of these by 2, you would get 2 over 4 minus radical 3 over 4. And that's the same as pulling this whole thing under its own. So 2 minus radical 3 over radical 4. And radical 4 is the same thing as 2. So that should be our answer. 2 minus rad 3. That radical of that whole thing over 2. Let's double check to be sure. And there it is. And I think I may have forgotten to write that. Nope, the negative. Yeah, negative was here, but we forgot to write it here. So there's the negative sign. Alright, tan 345, so the tangent identity is, you can see it right there in the bottom left. Let me rewrite that right here so we have it. So the tan of theta over 2 equals plus or minus this thing. It's 1 minus cos over 1 plus cos of, in each case, of theta. So again, this angle, 345, represents some angle that we cut in half. So if theta over 2 is 345, what would just regular theta be? We'll multiply both sides by 2 to do that, and we'll get theta is equal to 690. So let's figure out where we are for 345, first of all, because that tells us what's going to be the plus or minus in front of that radical. Okay. And then secondly, we'll figure out where 690 puts us. So here's 90, 180, 270, 345 is approximately right there, and that's in the fourth quadrant. So in the fourth quadrant, it looks like only cosine is positive, so that means we're going to pick the negative right there. And then where does 690 put us? So I'll use a different color for that. So 690, well, we go all the way around, that's 360. And then if we go around again, that's 360. Here's 540. If we went all the way around, that would be 720. So we're going to stop short of 720. 690 puts us still in this fourth quadrant. So that means cosine is still positive there. Okay, so that's good to know. And then this question is 690 has what as a reference angle? It's this reference angle right here. Remember, 2 full rotations is 720. So what's the distance from 690 to 720? That's a distance of 30 degrees. So this theta angle right here is the equivalent of a reference angle of 30 degrees. And that will be useful for us to know. So we're being asked to find 1 minus the cosine of 690 over 1 plus the cosine of 690. We just said that 690 is the same as 30. And we don't have to change to positive or negatives because we're in this fourth quadrant. 690 puts us in the fourth where cosine is already positive. So we're going to have 1 minus cosine of 30 over 1 plus cosine of 30. The cosine of 30 we did on the previous problem. I think it's radical 3 over 2. So this is going to be negative 1 minus radical 3 over 2 over 1 plus radical 3 over 2. And let's just simplify this some more. So this right here is going to be 2 over 2. So 2 over 2 minus radical 3 over 2 is right there. Over, and the same thing down here. This is also 2 over 2. So I'll have 2 plus radical 3 over 2. These 2's will cancel when you divide them. So here's what we have now. We have negative 2 minus radical 3 over 2 plus radical 3. And we'll put each of those under their own square root right here. And this is going to be another one of those nested radical functions. So we'll try to rationalize this correctly this time. So the thing that we need to do is multiply the top and the bottom by the same thing, because that will basically, that's the same as canceling these radicals. That this thing times itself is the same thing as that thing squared. So let me just write that here. That's the same thing as 2 plus radical 3, the whole thing being squared, and squaring and square rooting cancel each other out, and we're just left with 2 plus radical 3. Okay, now here's where the mistake happened last in that other problem. So we're going to FOIL this out. This whole thing's going to be under a radical. 2 times 2 would be 4. 2 times positive radical 3, and then 2 times negative radical 3. Those will cancel each other out. Those are like a difference of squares. And then finally, negative radical 3 times positive radical 3 would just be negative 3. So 4 minus 3 is just 1. Square root of 1 is 1 over this. And now there's one more rationalizing that we'll need to do there. So we will rationalize 2 plus root 3 with its conjugate, 2 minus root 3. Oops. And same thing right here. And then I keep forgetting to do this. We have a negative here, so that means we still need a negative here, and we still need a negative here. And that would be good at the end to check with the calculator. So let's deal with the top first. Negative 1 times 2 is negative 2. Negative 1 times negative radical 3 is positive radical 3. And the bottom, when you FOIL out the bottom, it's going to be 2 times 2, which is 4. The outside terms and the inside terms will cancel again, because that's what conjugates do. And then positive radical 3 times negative radical 3 is just negative 3. 4 minus 3 is 1, so this whole thing becomes 1, and anything over 1 is itself. So negative 2 plus radical 3 would be our answer, and hopefully we got this right. You can see that was a lot of work. These problems do take quite a bit of time to get used to and to do. That's what we got. The only difference is they wrote it in reverse order. So radical 3 minus 2 is the same thing as what we have. If we just put this thing in front, radical 3, and we put this thing second, that's what we got right there. Alright, a couple more here. So these are still half-angle identities. The only difference is let's change these into degrees. So this is the same as 105 degrees. And that means theta over 2, some angle that we cut in half is 105. So let's find the actual angle. If we multiply both of these by 2, we'll get 210 degrees is theta. So let's figure out where that puts us. 105 is in this quadrant where the only the sign is positive. So that means cosine of theta over 2 will be negative down there. So let's put a negative in front of that big radical. And then we want 1 plus the cosine of theta, and the cosine of theta is, we just found theta is 210. Remember, it's not 1 plus 210, it's 1 plus the cosine of 210. And the question is, where does 210 put us? 210, well, here's 180 right here. 210 is about right here. 210 is in quadrant 3 where only tangent is positive. So that means cosine of 210 will be negative. What's the reference angle for 210? It's this angle right here that gets us up to 180. So what do you have to travel to get from 210 to 180? You have to go 30. So this is the same thing as the negative of 1 plus cosine of 30, but the negative of cosine of 30, because we're in, again, the quadrant where cosine is negative. So let's simplify that. So negative radical 1, and then cosine of 30 is radical 3 over 2, but the negative of that would be negative radical 3 over 2. That whole thing is over 2. Okay, then we'll split this, so 2 over 2 minus radical 3 over 2. 2 over 2 is the same as this 1 right here. That whole thing divided by 2 is going to be like this. It's going to be 2 over 4 minus radical 3 over 4, and we can just combine that into one fraction, so it's going to be 2 minus radical 3 over 4, and we can put each of these under their own square root, and the square root of 4 right there is just equal to 2. So there's our answer. Radical 2 minus radical 3, and I keep forgetting to do this. We had a negative here, that means it's still negative right there. So this is what it is, and that's exactly what we came up with. Okay, last one for this section. The next one is a different topic, but here's the last one. This is another cosine one. Cosine of 5 pi over 12, that's the same thing as 75 degrees. So that means the angle that we cut in half gave us 75. So if we now multiply both of these by 2, that means theta is 150 degrees. 150 is in quadrant 2. It's about right here. And in quadrant 2, all students take calculus. In quadrant 2, sine is positive, but cosine is negative. So here's how we decide. So first of all, theta over 2 is in the first quadrant. 75 is in the first quadrant. So if we look at our formula again, here's our formula for cosine of theta over 2. It's plus or minus this whole thing. And I always forget if it's plus cosine or minus cosine. It's plus. Okay, so now let's just fill this in. So first of all, how do we decide if it's plus or minus? This decision comes from where theta over 2 is. Theta over 2 is 75. That's the first quadrant. Cosine is positive in the first quadrant, so that is why it's positive. 1 plus cosine of theta, we found out that theta is 150. So cos of 150 over 2. What's the reference angle for 150? Okay, it's this one right here. That reference angle is 30 degrees. So that's the same thing as the cosine of 30, but the negative of that, because, again, we're in the second quadrant. And so what is that? Cosine of 30 is radical 3 over 2. Again, negative, because for a reason that we already said. And just to show you an alternative way that you can simplify this, you could split this down the middle. So you have 1 over 2 minus radical 3 over 2 over 2. And radical 3 over 2 becomes radical 3 over 4, just like that. Then this becomes the same as 2 over 4, so we have a common denominator. So you have 2 minus radical 3 over 4, and this is very similar to, if not almost identical to that last problem. So the radical 4 on the bottom becomes a 2. That's almost the same as the other problem. The only difference is the last one was negative, and this one should end up being positive, and it is. Alright, now we want to practice doing identities, proving identities with double angle and half angle. And in this case, we put the double angle. How do we know that we're supposed to use that? Because that's a double angle there. That's a 2x, and the same thing right here. That's another double angle. Alright, so the key is to kind of look at this carefully and see how can we, obviously we always want to start identities by picking the harder looking side. The left side is harder here, so we'll start with that. And then we want to end up with a cotangent. Okay, and just to recall, cotangent is the same as cosine over sine. That's what cotangent is. So we have to pick here. We have kind of several different options for what we want to change cosine of 2 theta into, or cosine of 2x. But we would like it to turn out to be this. We would like it to have cosine in the top. So let's pick the one that only has a cosine in it and just see how that works. So 1 plus cosine of 2x, I'm replacing with this. I'm replacing with that identity right there. So 2 cos squared minus 1, and that whole thing is over this thing. It's over sine squared. Let's see what happens. Well, the 1 minus 1 cancels. We're just left with 2 cos squared over sine squared. Well, what is cos squared over sine squared? That equals cotangent. So we have 2 cotangent squared, and there it is. We're done. We proved what we needed to prove. Alright, same thing right here. So we want, this one we want a cosine to the 4th showing up. So that means we want a lot of cosines here. We should probably pick the one that has cosines in it, which is that same identity we just used. Right, because notice we're trying to prove cosine to the 4th. We don't see any sines there. The other two versions of this identity right here have sines in them. So let's pick the one that has cosines alone. So this thing is equivalent to 2 cos squared minus 1 That's over sec squared. Okay, same thing, the 1 minus 1 cancels, so we're left with 2 cos squared over sec squared. And then here's what we have to remember, secant is the same as 1 over cosine, so this can be changed into 1 over cosine squared. Dividing by that fraction, dividing by 1 over cosine is like multiplying by the reciprocal, which is cos squared. 2 cos squared times 1 cos squared is right there. It's 2 cos to the fourth, so we are finished at that point. Alright, this one, verify an identity. So this is cotan squared times this, and in terms of which one is harder, well, they both look fairly complicated, but let's start by simplifying the left side. Let's just distribute this and see what happens. So cotan squared times 1 is cotan squared, and then this will be cotan squared times tan squared. But remember, cotan and tan, those are like reciprocals. So cotan is the same as 1 over tan, and this thing is obviously still tan squared, so those will cancel, and we're going to be left with cotan squared minus 1. Okay, so the question is, what does that equal? That doesn't seem to help us very much. Cotan squared minus 1. What does that wind up being? Well, we're not sure yet, so let's start changing the other side. Let's see if we can make them meet in the middle. Alright, so we know that we want a cotan squared minus 1 to show up. Well, let's look at cos 2x. What could we change that to? So remember, we want it to be cotan squared, and cotan squared is the same as this right here. That's an identity. So we have the sine squared on the bottom. We want a cos squared to show up on top. So let's pick one of the ones that only has a cos squared in it. Okay, and I'm just trying to take a look. Actually, you know what? So that leaves us these two right here, and the question is, which one do we pick? Well, let's look at the other thing that we had. We have a minus 1. So if I change this cos 2x, if I change it to have a sine squared in it, I'm going to have a sine squared divided by that sine squared. That's going to give us our minus 1. So if that's not clear to you, let's just write this out. So I'm taking this and I'm using an identity that has a sine squared in it, and you'll see why. So it's this one right here. That's over sine squared. Now let's split this down the middle. We have cos squared over sine squared. If you weren't sure which identity to use, you could try all three of them and you'd eventually discover which one works. The reason I chose that one is because I saw that I wanted a 1 right there, and I saw that I had a sine squared on the bottom. So I knew that in order to get 1, I would need to have a sine squared on the top. So this equals 1, and this right here equals cotan squared. So you have cotan squared minus 1, and that's what we got on the other side. Alright, this one right here is another identity. 1 minus tan squared on the one side, and then we have this equals cos squared over cos 2x on the other side. So the question is, how do we simplify that right there? It's not a very obvious strategy here, so let's think of a couple ways we could do this. 1 minus tan squared, there is an identity for tan squared, and it's this one right here. Tan squared plus 1 equals secant squared. Let's just think if that's gonna really give us anything helpful there. I don't think it necessarily will. So let's start by changing the right side here. So cos 2x, and the question is which one if any do we use? And it's not obvious what to do. But here's the thing, we want it to be 1 minus tan squared, and here's a cosine identity that has a 1 minus something. So let's start by changing into that one. It's not obvious what to do here, but we may as well try it. So we have 1 minus 2 sine squared. Alright, question is, of course, now what do we do? Because it's again not obvious what to do from there. So we have cos squared over 1 minus 2 sine squared. And then kind of like an impasse, we're not exactly sure what to do. Here's what we can do though, we can try to do this. Sine squared, remember this identity right here. One of the things that we can do is, when in doubt, use well-known identities. Okay, so there's a well-known identity right there. And so we have a sine squared, so let's solve this for sine squared by subtracting that from both sides. So sine squared is equal to this. So I'm going to replace this. We still have the cos squared on top. I'm going to replace 2 sine squared with 2 times this thing and see if that leads us anywhere. It might, and it might not. So we'll have cos squared over 2 times that. We're going to have 1 minus 2 negative 2 times that would be positive 2 cos squared. And this thing becomes cos squared on the top still over 1 minus 2 is negative 1. We still have that 2 cos squared. Okay, so that didn't really lead us anywhere. Sometimes you have to go down a couple of dead ends and see if that leads you anywhere. So let's box these off. Let's box off this one, and let's box off this one. We're kind of at an impasse right there. We can't really do a whole lot more from that point. So let's see if we can't change the left side and have them meet in the middle. And one of the strategies that we use when we're stuck is, when in doubt, change everything to sines and cosines. So let's try that right here. We'll do 1 over 1 minus, and then let's change tangent into sine over cosine, see if that leads us anywhere. Okay, so this is the same as 1 over, we need a common denominator with cos squared, and so 1 is the same as cos squared over cos squared minus sine squared over cos squared. This looks like we might be getting somewhere here. So this is going to be 1 over, and then let me use a different color so you can see this big fraction bar is kind of separating those two. Okay, then this thing becomes, when we combine it, it's going to be cos squared minus sine squared over cos squared. And then dividing by that fraction is the same thing as multiplying by the reciprocal. So the reciprocal of this is cos squared over this, and that's the same as cos squared over cos squared minus sine squared. And actually I see a way to get to the right side. Now this right here, this is an identity. That's actually equal to cos 2x. And you can verify, look at the 3 different versions of cos 2x. Here's one of them, cos squared minus sine squared. So we pretty much just proved it right there. We have, let's double check, we have cos squared on top, and we have cos squared on top. We have this thing, which equals cos 2x, and there's our cos 2x. So sometimes you got to try a couple different strategies before one of them works. Alright, this is the last one. The next one is equations from 13.5. Last couple identities, double angle identities. So, okay, let's take a look at this one. So we have sine of 2x, and here's the identity for sine of 2x. It's kind of nice because we don't have to decide really. We can just immediately plug it in. So sine of 2x is 2 sine cosine, and the bottom is this thing, cosec times cotan squared. And when in doubt, change everything into sines and cosines. So let's try to do that right now. So 2 sine cosine. Cosecant is the same as 1 over sine, and cotan squared is like cos squared over sine squared. So when we keep simplifying this, we're going to get still 2 sine cosine in the top. This thing becomes cos squared, and sine times sine squared becomes sine to the third, and that's a good indicator because we're supposed to have a sine to the third somewhere. Okay, now let's simplify this. So 2 sine cosine times the reciprocal of that, because dividing by that fraction is like multiplying by the reciprocal. And so we have sine cubed over cos squared. Okay, let's see what we have right here. So we're almost there. We just need to kind of pick these parts out right here. So we need a sine cubed, and we need a 2 sine cubed. Well, there's a 2, and there's a sine cubed. And the question is, can we get a tangent? And I see a way to do that. That cosine will cancel, and one of those cosines will cancel. Let me just rewrite this. We have 2 sine cubed times we have a sine over a cosine. So times sine over cosine, and what's another name for sine over cosine? That's the same thing as tangent. So we're done at that point. We proved what we wanted using that double angle identity. This one is another cos 2x, and these tend to be harder because there's 3 different versions of them. So let's see if we can start with the left side. Left side looks a little bit more complicated, and let's distribute this. So we're going to have cos squared minus cos squared times tan squared. When in doubt, change everything to sines and cosines. I'm going to change tangent into sine squared over cosine squared. Those will cancel, and we're left with cos squared minus sine squared, and hey, that's an identity. That's the same thing as cos 2x. Now the question is, how do we get from cos 2x to this whole side? Well, we have the cos 2x. Let's make these meet in the middle. Okay, so let's take tan cotan, and we hopefully will get something to cancel. Cotan is the same as 1 over tan. So those actually cancel. We're left with cos 2x times 1, and cos 2x times 1 is equal to that right there. So we're pretty much done. We had those meet in the middle right there. So that's the end of 13.4. The very last section in this practice test is about the problems from 13.5, and that's what we'll do next.